Hi guys, I'm going to share a sketch with you that I wrote to read this quadrature encoder, and it reads the positions of the clicks that it goes through. There's 20 clicks on this encoder, and right now let me just show you what it does. When I turn it, it is reading the positions. You see that? Positive direction, minus direction, and then I also have it where you can press the button and it resets it to the next line, and then you can use this. So you might use this for selecting menu items, for example, or inputting data into your program. Let me show you how this works. First, let me just briefly review with you how a quadrature encoder works. There's two lines that it has. They're labeled different on different models. This one has a label clock and one is DT. They basically output two square waves that are out of sync by 90 degrees. And so as you turn the knob, one of the channels will be putting out a square wave and it lags the other one a little bit. And when you look at the levels of the square waves, one of them is, the top one, for example, is 0, low, bottom one is low. This next phase, the top one is high 1, bottom one is low 0. This next phase, both of them are high, so 1 and 1. And if you follow this along, you'll see a pattern of ones and zeros. And the 1 and 1 occur on this model when it's at a detent or a click. So the sketch that I wrote looks for the 1 and 1, and when it picks up that the position is 1 and 1, it will look at the surrounding code to determine if it moved forward or backwards and increment or decrement its position. The setup for this is quite simple. In the file that I wrote that I will link on GitHub for you, I just specified that the clock for the encoder is connected to GPIO 32, the DT is 33, switch is 25, and the plus or the voltage, I'm getting 3.3 volts from the voltage regulator. Ground is connected to ground, of course, and then the voltage regulator that I'm using has a VN, which is connected to the 5-volt pin of the ESP32, and ground, and the output is going to the encoder. There are two classes that you will need to have in your program, the debound switch class and the quadrature detent encoder. This first one handles debouncing the switch and also the encoder data so that you are not reading extraneous inputs as it's transitioning between highs and the lows. And the quadrature detent encoder is what does all the sensing and calculations. You're going to make an object of the encoder and use the quadrature detent encoder class, giving it the pins you're using, 32, 33, and 25 for the pen. And in the setup procedure, you'll basically be doing encoder setup. This setup function connects the pins to the appropriate pins of the ESP232 and also sets them up in the appropriate input modes. In the loop function, the main thing to notice is that you will be calling the encoder update position code. This code works on polling the encoder, so you'll be looping. Whenever you loop through, you'll update the information on here. It doesn't work on interrupts. When there's a change in the position, it prints out the position. The switch code is down below. Encoder switch pressed. If it is true, then the user pressed the switch one time, and the encoder is set to position 0, and then it also prints a new line, and that's how I get the new line. Let's look at the components that I'm using. This is the encoder that I'm using. This is a Teyleten Robot KY-040 Rotary encoder, and it says that the number of pulses in 1 cycle is 20, and that's the 20 detents that it has, and it actually outputs 100 cycles in the whole turn. When you read reviews on this model, you'll see that the knobs don't fit the shafts of the encoders, and I thought that was silly, and I I am like, I wonder if that's true, and sure enough, it is true. The knobs do not fit the shafts. So I actually had to use a drill bit and a drill to make the hole a little bit larger in the knob so that the shaft of the encoder fits in here. Yeah, so these are 5 pieces for $8.99. Can't really beat that. I have that on Amazon. This is where I got that from. And let's look at the other 3.3 volt regulator. That is the AMS 1117 3.3 DC regulator. So you're getting, gosh, how many pieces? 10 pieces for $7. So that is that. And then the ESP32 development module is right there, okay? I will link the GitHub so that you can download the sample code that I'm using, and it's in the encoder example. Right now it says encoder 17 YouTube, but this might be a different number when you're looking at it in case I need to make adjustments to it. Inside here, you'll find this file, encoder 17 YouTube, or the higher number. Select the highest number you find. And what you'll do is simply click on that file, and then you'll want to download that and save it to your computer. And then you can open it up into your Arduino IDE. And as long as you have the wiring hooked up as I described in the file, hopefully this will work for you. I would love to hear comments on your experience. Please share, tell me what you did and how it worked out for you. And if you find this helpful, please like and support my channel. Thank you very much. Peace out.